morning, ladies and gentlemen. Welcome to the world introduction of the Quickmaster DI, the world's most compact postscript 4-color offset printing press in a 46 by 34 centimeter format. I'd like to begin by introducing our digital team. Back behind all those hot lights is our model, Isabella. Hofer will be operating our digital camera. Behind me is Matthias. He's in charge of our digital pre-press. And Calvin will be operating a Quickmaster DI printing press. Now, as I'm sure you've already noticed, we have a complete digital printing system set up behind me. We're about to demonstrate the speed, reliability, and high productivity of the system. To begin, we're going to start over here at our digital camera. Hofer is now taking a series of live digital photographs, one of which we'll choose for use in our live digital page. What I need right now is a volunteer out of the audience to help us in choosing that photo. Do I have any volunteers? Way in the back. Please, would you mind helping? You speak English? Any takers? Yes, sir. Thank you very much. This could be a very long demo. Hi, what's your name? Freddie? What I want you to do, Freddie, is to take this thing, don't touch those buttons, the plus or the minus, and you can advance through our live shots here and pick the one that you think we should use in our job. For you folks out there, you can look at the monitors overhead and see exactly what he's doing down here. Whichever one you think looks best, just tell us what number and we'll go with it. They all look pretty good, don't they? It's a tough choice. That one? Number 8. Matthias, number 8 is the choice. Whoa, he gets away too quick. We have a small gift for your efforts. No, we don't. I'm sorry. You're supposed to have a gift for your efforts. Stay here after the demonstration. I'll make sure you get it. Thank you very much. Oh boy. Now that our volunteer has chosen our image, what we're going to do is transfer the image data from the memory of the camera to our Power Mac via SCSI connection, where we'll use Adobe Photoshop to do some minor manipulation. While Matthias works on this, I want to discuss a little bit about the digital camera we're using here, the Sony DKC 5000. This camera should be thought of as no more than a photographic camera, like the cameras that some of you are carrying. The only difference with this camera is it doesn't use film. We use digital memory to capture the image and then send it to our page layout program. All conventional flash systems can be connected to this camera. As a matter of fact, it's the duration of the flash that determines the exposure time. The camera can be set to any exposure time up to 4 seconds. Each image that we capture is captured with a resolution of 5 million pixels. Now, this is equivalent to a 5 megabyte file with a physical dimension of 10 by 13 centimeters at 300 dots per inch. Using Sony's 3CCD technology and automatic color temperature compensation, our result is high resolution, but more importantly, true-to-life color images. At this point, we're going to say goodbye to our digital photography team. Let's have a round of applause for a wonderful job. Thank you very much, ladies and gentlemen. Now, if you've been following the monitors, you know how our digital data got from our camera into our Power Mac, where Matthias is now working on it in Photoshop. Once in Photoshop, Matthias is going to utilize the unsharp mask filter, or a softening function, to make the skin tones appear smoother. Now, for those of you who are familiar with conventional photography, you know that special filters are attached to the lens while the picture is taken, so you can achieve the same results as we're getting right now with Photoshop. At this point, our image is prepared. However, this digital camera captures images in RGB mode. That means right now we have red, green, and blue separations, but we need cyan, magenta, yellow, and black separations. So we're using Adobe Photoshop to convert the photo. The printing press uses the CMYK separations to image its plates and then print. After the conversion into CMYK, Matthias will save or has saved the image as a TIFF file. Then, as in a normal workflow, we utilize a page layout program to assemble all the pieces before going to press. While Matthias puts the final touches on our page, let's talk a little bit about the DI rip and file server. The DI rip and file server runs on a DEC Alpha Station 200, which utilizes the fastest chip, or one of the fastest chips on today's market. It's the Alpha AXP chip, and it runs at 233 megahertz per minute. Now the Quickmaster DI, it's the ultimate system for digital printing. Why do I say that? Not simply because it's from Heidelberg, but because it is a complete system that produces excellent quality. As an innovator in this field, we at Heidelberg know that the productivity and the quality of any digital printing press depends on the ability to accurately receive job data from the prepress. Unless the postscript rip is quickly interpreted, or the file is quickly interpreted by a postscript rip, the potential of the press itself cannot be fully achieved. Sophisticated, efficient job data handling is the key to seamless production of one job after the other. Now, the Quickmaster DI has been specially designed and optimized with this in mind. The system components are, of course, the press itself and the rip that I just described. To give you an idea how fast our rip is, I talked about the speed just a minute ago. This is similar to the page that we'll be printing for you. This is one we printed either earlier this morning or yesterday. This represents 70 megabytes of data in Quark Express. We ripped this page in 4 minutes. And for those of you who are familiar with rip technologies, I'm sure you'll agree, that's pretty fast. Both the rip and the press are connected by a fast online Ethernet connection. As you can see, we at Heidelberg are committed to an open system environment based on PostScript, which is the industry standard. Our job is currently being ripped, or should soon be sent to the rip. While this is still happening, I'd like to discuss a little bit about how our job has traveled, how far it's traveled so far, and also discuss some more of the features of the DI server and rip. This graphic shows, and I'll use this as an example so you can see it a little better. The picture on the monitor is a little bit small. This graphic shows how a digital page is put together in our prepress. First, copy is entered into a computer, and that includes such elements as the text you see here, and we're changing this text for every demo. Secondly, graphics. Any graphics needed for a job must be put together in a graphics program. There are a number of them on the market. The logo at the bottom of our page, for example, is a graphics file. It was produced in a drawing program. Thirdly, scanners are used to capture images or scan photographs to be included in our digital job. Now, we're using a digital camera. There are a number of types of scanners on the market. We have flatbed scanners, drum scanners, and of course, digital cameras. Why do we use a digital camera here? Well, first of all, speed. All you nice folks witnessed Hofer taking 10 images. Our volunteer then came down and picked out one of those images. That image is already put in a page and on its way to press. Secondly is the quality. This is first generation information. We have no film negatives or any film. It's a filmless camera, which brings me to my final point. This whole process, the entire process to producing this job doesn't use any film at all. On the monitors, you can now see how the digital data comes together in a page layout program. For this job, we are utilizing Quark Express. Now that the page has been assembled, it contains all of the data formats that I just discussed: text, graphics, and photographs. From here, the RIP accepts PostScript information and generates 4 bitmap files, one for each of the 4 process colors: cyan, magenta, yellow, and black. The RIP is an integral component to the Quickmaster DI system. It has been optimized for direct imaging, and it has a powerful interface to the press that guarantees fast, consistent, and top quality ripping of files. Functions such as automatic job spooling and queue management make it extremely easy to send files to the press. Additional functionality includes the ability to check the progress of a file while it's being ripped, as well as view the bitmap data and PostScript information after it's been ripped. The RIP runs under Windows NT, which is a user-friendly interface, and the RIP also offers multitasking capabilities. This allows for the spooling of jobs to happen at the same time that you're ripping other files. What you get is incredible performance complemented by a logical and easy to understand graphical user interface. The screening algorithms that we use with the Quickmaster DI's RIP have been specially adapted for Heidelberg DI technology. Typically, jobs are imaged at a resolution of 1270 dpi and are printed at 150 line screen ruling. As for proofing, various digital proofers are available on the market for use in conjunction with the Quickmaster DI. Units such as the Iris by Cytex is an inkjet type system. We also have dye sublimation proofer down here, 3M Rainbow. Both of these devices are controlled from your prepress before going to press. It is also possible to proof your job on either of the monitors that comes with the Quickmaster DI system. Here, several levels of zoom are available to view your job down to the individual pixel level. Now in the prepress, they use this function to check the job before it's sent to press. As a result, if any problems occurred with the conversion of the PostScript file, and I know none of you ever had any trouble with converting PostScript files, but by chance, if something happens with that, he can quickly catch it at that point and correct it before sending it to the press. The press operator, he uses this function to check the printed sheet with the bitmap data. Now I'd like to call your attention to our Quickmaster DI, which has been working since the beginning of our presentation. In that time, several processes took place simultaneously. Calvin here was printing our first job, while the second job, as you know, was being prepared in our prepress. Then just a few moments ago, you may have noticed Calvin stopped the press and performed a complete job changeover for our new job. Please note that when Calvin did that, he started the stopwatch that you see on top of the press. You can keep an eye on that watch to see how long it takes for us to get from the last sheet of our first job to the first sheet of our new job. On the monitors, you can see the Quickmaster DI's control panel. Calvin simply selected our new job on the monitor, and with the push of a button, he started the entire make ready. Now, the first step in getting the new plates on the press is accomplished by using a revolutionary new plate loading device. With this device, new plates are reeled off of a supply roll housed within the plate cylinder itself. At the same time, the old plates, or the plates from the previous job, are wound onto a take-up reel, which is also housed within the plate cylinder. This takes place in just seconds and is done in all 4 units simultaneously. To gain a better understanding of how this happens, how the system works together, please watch this brief computer animation.